So I guess I'll get started because there's no break in between.
Not yet.
Yeah, no. So this is about onboarding. So we've been talking about the Nephio SDK for over one release cycle now. I think much of the discussion is on whether or not we want to do Helm onboarding. I think that part is we have reached consensus. So for R3, we are focusing on Helm onboarding for the SDK. So one of the things really quickly, the rationale behind why, as of today, we have two NF operators in the community. It will be the same for L3. L3 we still only have two. One from FreeFireGC, which is just core, OAI, which is core and RAN. They pretty much follow the same patterns. We take the Nephio CL, which is just NF deployment, and it watches it. So the operator watches that. It takes that input and whatever vendor extension that you may have, which FreeFireGC has one and OAI has several, and it generates the resources that was needed, Kubernetes resources more specifically needed, mainly deployments, config maps, services, and things, and then just apply them. And then once that is done, they own the NF deployment resource, obviously, because operator owns the resource you watch, and also owns all the resources, for the resource, and owns the resources that they created. So now, basically, if you really think about it, there are three different components on an operator. On this particular case, one of them is the template, where you're gonna fill the templates for config maps or for your deployment, or if your daemon sets or or stateful set or things like this. The API clients that executes those templates that is filled out, and for config map particularly, which both of these network functions are following as the network function configurations, the operator also generates the specific configurations for any of this. So in essence, what happens is if you change any of this, you have to have a new version of operators and roll it out. So that's actually very airtight. The STK. So when we started STK effort, when we started the project, the community generally said that writing operators, writing Golangs are things that they are not comfortable with. Almost 2 years later, I think that's less of a concern. I think more of a concern is whether we have like a standard framework to onboard things easily, particularly for network function vendors. And one of the most frequent feedback that you will get out of the network function vendors is if Nephio has to be at a stage where it's worthwhile for them to be on board. So obviously there are many other things that are working. There are many community members working on that aspects. But then if they are onboarding, cutting through completely to Nephio is probably not realistic. So they would still maintain as a product a bunch of Helm charts that they have to do. So ideally, what we want to do for an SDK is to be able to onboard their Helm charts unmodified onto the system, at least for day one operations. And so for R3, we are moving towards that direction, particularly for release 3. The SDK basically only aimed for one use case, which is onboarding network function vendors Helm charts as a deployment mechanism, unmodified. And using this, the idea, this would be the reference implementations that we'll provide. So that's also decided in some of the SDK meeting that we had. So on the top part, first there's the tools. The tools will at least generate 2 packages. One of them is your operator. So you're creating, obviously the SDK is creating an operator. We're not touching the management cluster yet for SDK. So for R3, we're generating a operator. The operator package would have the operator that you generated plus the other things that you may need it to deploy it as a preparation step before you can actually deploy a network functions, and also the second package, which is your actual network function package. And once you have those, you load the user loads the operator package. So for now, the Flux Helm controller is probably what we're going to use as a reference This is part of a vendor package. So you have the freedom to use whatever Helm execution engine you want. The reference that we'll use is the Flux Helm, because well, we've done the work to bring a FreeFiGC at least out of that. And then so once the dependencies controllers and all that stuff is working, you should be able to just get that without loading the entire deployment specs for Flux Helm. But then for now, probably for L3, I would imagine you would have to specify that. And then the vendor logics would be running as an independent thing sitting around. That would also be part of your operator package. This is something you have to develop. For those who actually attended the session on Tuesday, so that I did a demo, which actually does the proxy operator, which is the control runtime that we're going to use. And the workflow is when you load the operators, the proxy, the vendor logics, the FluxHelm controllers will all be running, and then user is responsible for putting the Helm charts into a repo that is accessible by your workload cluster, and then they would specify that. So your NF package should have a vendor extension CL that would be specifying the location of which version of the Helm charts that you're deploying out of your network functions. And then once that is loaded, your network function would just magically happen to be deployed. So that's what the SDK, the components of SDK is supposed to have. I did a demo. I did the POC that I hopefully will clean up. It's pretty hacky right now. I'll clean up in a week or so and make it available on. There is under Nephio experimental, I created SDK-POC branch, a repo. So I'll load it over there when I clean it up. There's no unit test yet. Unit test when we go back to the SDK repo. And then so in here, when I did the POC, some of the responsibility breakdown is you have the tools, which is Dan from Ericsson, which most people call him Dishon. It turns out he told me that the J is silence, so it's actually Dan. It's working. He actually did the work of using Nephio SDK wrapping KubeBuilder. So like any KubeBuilder commands, you can create controllers and APIs and your own API versions and domains and everything that you can have. Those are for the extension pieces. So the SDK allows you to do that because it's KubeBuilder. And also we would extend that CLI to allow you to specify which version of NS deployment that you actually want. And then that would map into a deployment spec in the operator package that would have the proxy. And then you can define which Helm execution engine you have. You have to write your own deployment for those. And then hopefully that would be completely eased up in the future when the dependencies things from Vim would be is a little more defined. And then, okay. So the proxy is responsible for the Nephio CL. So they're the one who is updating the status field of NF deployment. Basically, that's the only one we have right now. And then it uses gRPC on the backend. So it sends a gRPC message to the vendor logic, business logic. And then that proto definitions and things are maintained by us, the community. And then the actual manages connections. So for now, UPF is one business logic. When I start writing SMF and others for FreeIGC, it will be a different backend business logic. It doesn't have to, but then it's more like extending the code to ensure that we can manage all the gRPC connections. And then the vendor logics is the one that are obviously you own your own vendor extension CLs. And then if you want status updates, that's up to you. Because again, you can generate that through the KubeBuilder directly. As Dan said, the KubeBuilder allows you to create a template code off of what you want to create with complete freedom. So right now, by default, if for those who actually use KubeBuilder, it gives you a reconcile and a main.go. The aim is to also create a gRPC server. So that's where you actually get all the things. So you only have to write the callbacks. But then if you do want to watch your own resources, that is possible, although we do want to see how that would work. Because if right now I have one vendor extension for UPF, which is the location of the Helm charts and the repo and all that stuff, all the versions. So if the controller from vendor logic is watching that, but then they're also getting that reference from NF deployment, a gRPC message, then the synchronization between the two is something we have to work on. The benefit of having watching your own CL in this case is if you update just the Helm charts without changing NF deployment, you can just do that by pushing the package down. The NF deployment itself won't change because it's just a reference. The vendor extension CL is just a reference on NF deployment. So that being the case, you have to have something watching it to actually update if you actually switch to a different Helm chart or new version of a Helm chart. And I haven't done that yet, so this is another thing to have to do. But then you should have a server stream gRPC connection on your vendor logic, so you can periodically make updates to status and send it back to the client, so the proxy will get that and update NF deployment correspondingly. So I haven't done that on POC. I'll do that in the next several weeks. Finally, obviously, the biggest thing for vendor logic in the Helm onboarding scenario is you're taking the NF deployment plus your vendor extension and generates what is needed for values.yaml and whatever the Helm invocation is. So in Helm for Flux Helm will be Helm released resource. That logic right now I wrote it on a POC using the regular template on Goat and just map it one field by field, which gives you no savings based on what we have right now for operator. Moving forward, and I'm still not sure if we have that for R3. Both Vim with Kform and Tao with his POC has solutions where you can map resources from different sets of resources and generates a different set of resources and do it in runtime. So if we have this, and there is actually an issue for that, I GitHub issues on this, we would be able to create that business logic with Dell writing code. So all you have to do is map the fields of different resources into the destination resources that you actually want. You may still have to write some backend code for updating status and all that stuff, but at least for applying this and have Helm creating your network function, deploy the network functions for you, you should be able to just do that using YAML. So in essence, for R3, these are things that we wanted to do. I wouldn't say all of them has people's name attached to them. But then we have a new community member that joined recently, so I'm hoping that he can pick up some of this stuff. But anyway, so as I said, Dan is already taking on the base SDK tools of the QBuilder wrapper. He did that already. And then so if he has time, if he comes back, hopefully he can help out on the gRPC server generating part. And then the packaging is not that difficult. That's why hopefully Mickey or someone will take over. That is automatically generating a dummy custom resource and load it into the package for the NF package. And then also generating the operator package, which you get a lot of the CLDs and deployment YAMLs already out of QBuilder. So it's the matter of just bundle them and generates a cap file. So basically just a cap command, cap init. Sort them into a sort directory, do a cap init, that should be good enough. And then after that, the runtime, I'm doing that. So hopefully that would be working. It's already working, but it's working to a more full extent before when we get closer to the R3 timeframe. And then the sample, which is also something I'm working on, the FreeFiGC. So the idea is if everything works out, we'll replace the current FreeFiGC operator with what the SDK would generate. And that would allow us to have at least for FreeFiGC, I haven't talked to Sagar, so I don't think we're going to change that for AI yet. We'll have a fixed framework moving forward on this is what the operator would look like. And then ID, I'm not sure, even if Kform or Taos PLC, if we integrate those. I don't think we have community members that would do the work to push down on runtime. So particularly you need a runtime backend to execute for Kform's case, I guess is a DAG that comes in and then it executes that DAG. I don't have anyone working on that at all. So even if that becomes available, we'll still have to see whether or not we can make it by L3. Yeah, so all of these things are on GitHub issues. Is it just one page? All this SDK, and then some of the early ones. But this is the main epic for L3. As I said, the CLI framework is Dan is taking over this. The reconciler, the general reconcilers, the proxy, which I'm doing. The vendor extension handling and package generations are all the tools. That is pretty empty. So it's no one taking on that right now. So hopefully someone would volunteer, Mickey particularly. I mean, hint. The Flux thing is already done. So thanks for Fiacra. This is already done. And in fact, I wrote my POC based on what is being documented here. It works very well. The FreeFi-GC operator, the whole thing obviously will take some time. I have a UPF one that is already working. It takes a gRPC and basically just creates a UPF through a config map that has the values.yaml and generates a Helm released based on the extension CLD that comes in. And this is no longer L3. And this is when Kform and things becomes available, we should be able to take that and hopefully have a runtime that would be executing whatever forms that input will actually come in at runtime. So once we have this, especially if we have this, then vendors should be able to onboard their Helm charts for deploying day one, using the existing Helm charts with no modifications, and bring up the network functions through Nephio using NF deployment. So you can leverage the specialization that is working today, and then using Helm as an execution to put it out. So that's the goal for L3. Any questions?
I guess
Okay,
not.
cool.
Oh.
Yeah, everyone's great.
Leading questions, right, from these. So, a lot of this is code written in Go, right? But we had a really cool implementation from OAI when they brought their components in as an experiment. And actually, they asked me for advice when they came in. And I said, you know what, maybe try to do it in Python, right? Let's see if Python can actually do it, right? I was hoping we can learn from their experience and see if it worked.
Right.
I think it worked pretty well, right? Yeah. And question for us as a community, we can be very Go-centric without a doubt. We can say that you need Go to write anything that has to do with Nephio. We can also be open to Python, right? And it doesn't necessarily change this architecture, right? It's more about,
so the idea of using our gRPC is the language is agnostic on the business logic. So we're still generating our gRPC server to help out. So if that's the case, I don't think we'll be generating different languages yet on L3. But then I do understand that Python is pretty popular for DevOps folks, particularly. So this is definitely something on the roadmap. Generating a Python gRPC server versus a Go one's actually even slightly simpler. But then it's more like someone's do the work. And then right now, for L3, all we can commit really is just generating a Go one first, and then switch over to the FreeFi-GC pieces, where I can hopefully convince Saga to also move over to SDK, and then we'll be hopefully doing the Python piece. Go ahead.
So would that mean that we need to specify that gRPC protocol as some kind of API that we?
So there is there's a tools from Kubernetes that takes a struct Go input and generates a proto-C. So I fully aim to get that going, so we don't have to write a proto-C ourselves. Yeah, I can generate any type of things that we want out of the proto-C tools. So it generates a proto files, proto files, and then you can use proto-C to generate whatever you want. Go, Python is Java, any destination. Sorry, go ahead.
No. Just regarding documentation, do you have
onboarding documentation or like?
Not yet. Documentation. It's all POC. So by R3, we want that to happen. We also, I mean, so one item that I haven't actually added in is that I want that to, if we wanted to make it into an R3 release, I want that to be part of the integration test also. So it will be an operator generated by SDK that will be loading into the test cluster. That would be fabulous. But you know, obviously when that happens, we need documentations. And
Anybody? Anybody else?
But it's better to say it than not to say it.
yeah, go ahead.
See, I think the reason why we are doing this, right? So first of all, I think we want to reuse existing Helm charts.
Yeah.
Right. If you look at what we are doing here, we first convert to NF deployment, and then we convert NF deployment back to the values.yaml, right? Is it not too complex? Because if we, from the management cluster, just generate the values.yaml and have the Helm chart execute without all the glue, it's going to be way more easy. And so that means that the operator, so the person with the Helm charts, what they have to do instead of writing all of this, they have to, at the moment, write a cap function that basically generates that values.yaml file based on the data that is coming from the management cluster. So I believe if you look to all of that, because at the moment we are rendering Helm charts, right? So I do agree we want to go to operators and stuff like that. But look at it, first step, what we are doing here is nothing more than a Helm chart.
Yes.
Right.
So John and I had that conversation. So this is my answer.
Yeah.
This is my answer.
So in other words, what I'm saying is you have the Helm chart to get deployed, but you still write an operator to do the more advanced stuff like canaries, upgrades,
No, I don't disagree with that. So John and I had this very long conversation on this because obviously you know him. He's proponent of everything's on the left. So my take is if you do day 2, the allocations of your resources, IP address and VLAN, should be done on the operator side. So if you can maintain that the day 1, which you still have the allocated IP address from day 1, would be done on the left, then there's actually an imbalance between the two. That was my big problem. There's an overlap between what day 1 and day 2 would do, and then I would prefer that everything's get centralized on the operator side when that happens. Because today, NF deployment gives you an explicit IP address. Imagine giving you a block. So if you want the left side to create a block out of the one IP address, then that block is one IP address out.
That you can do today. We have the ability to just get a block from the management cluster and have the IP locally resolved. We can do that today.
Yeah, but then one of them would be allocated by one of them would be allocated by the left side if you do everything on the left, right? If you're doing Helm on the management cluster, then that one IP address out of that block is now.
No, we just allocate a subnet. That's it. So you don't. So we can also. So today we allocate an address. But in order to allocate an address, we have a prefix. So what I'm suggesting is just do the prefix on the management cluster, which basically anyhow need to match to the switch, right? So you anyhow need to coordinate that. And then you just do everything local and we can support that today.
Yeah, but then the resources that you push down is still something looks like NF deployment that has a block of IP address.
But it isn't part of the problem. The business logic needs to be the vendor knows which parameters in the values.yaml need to be filled in with IP addresses, and vendor A, department A chooses one format and vendor A, department B chooses a different format. And well, you do because you don't want to have to expose that to the end user. You want to be able to just, the NF deployment handles IP addresses, network attachments, all those sorts of things consistently. And then the specialized code there will know how do you put those, introspect the right parameters into the right places in the values.yaml.
I think, yeah, so
it's very specific, but yeah.
No, I understand. But so basically, I'm still suggesting to allocate the prefix at the management.
Yeah, so that's true.
Right?
That is true.
So that remains,
yeah,
right?
That is true.
So that doesn't change.
But then we're not skipping the NF deployment. That was my point.
I would skip it for this case.
Yeah, but then you have to give an IP address on the Helm charts.
Yeah, but anyhow, they are using whereabouts. They are using local IPAMs. Anyhow, all these vendors that. Yeah.
It's a little.
But okay, that's why I'm saying it's controversial.
Well, I mean, it's a comment. It's part of the.
I'm actually on Wim's side of the controversy here. We're doing you know, the whole Helm support thing was, we had a lot of options and many scenarios. And to be honest, we haven't decided on one. We're kind of going with this for now, but the other
Yeah.
options are also on the table for support.
Mhm.
I'm always in favor of using tools for what they're supposed to do.
Mhm.
Once you start using tools differently, you get into challenges, right? So use Helm for Helm install, right? We don't have to hide the chart away. We have a Helm chart. Let's give it first-class citizen support and, but allow the exit route for actually doing something. We also have to prove why write an operator in the first place, right? So what are the advantages for day two? And to be honest, as a community, we still haven't proved it yet. It seems like we're suggesting a much harder way to onboard and you don't see the immediate benefits, right? So we need to show those benefits, right? To showcase the advantages. So also know that as long as we're using config sync has built-in support for Helm too, right? So to run Helm on the remote cluster, it doesn't, you say? It's well, it's limited. Well, we can boost that if we want. Config sync is open source. In my POC, I'm also using Helm directly. I'm just running the Helm command line, Helm install, and you're just providing its inputs. But you know, to the point, I don't think it's that controversial what Wim is suggesting. I think it's one of the options we had on the table too. And to be honest, we haven't still, I think, decided.
Yeah,
exactly
as an
the best
operator
way.
framework, obviously with Helm being doing mostly Helm doing day one, then we have to define the day two benefits
Yeah.
of using operator. This is a direction move towards that.
Right. But I think it's a good point. Let's not make things more complicated than they have to be. If we're using, as long as we're using Helm, let's just use Helm, right? Rather than hide it away.
That was a very final statement, but I mean, I think there's some benefits to hiding it away and not necessarily even hiding it away, but providing this abstraction and this sort of, I guess, a level of control over the input parameters that you have.
You still want the ability to automatically generate the inputs and things, and then for the Helm charts. Even if the backend using Helm execution, oh, sorry.
Let's maybe ask the question to the vendors. Is anyone going to use this at the end of the day, if it's available?
Yeah, it is. So
That's the
that's
key
my
question,
question
I
too.
think,
Because
we should
I'm
have
not
to
doing
ask,
this just for fun. Neither.
In Nokia, I don't think we will use this. I'm actually sure we are not.
I just promised Bala that I will have another question. Sorry. So do I understand correctly? I am working for a vendor, let's say Nokia, and we have a network function and a Helm chart. Right now, what I have to do in order to use the SDK is to write, one of the things that I have to do is to write that yellow box that is basically a gRPC server that knows how to manage my own Helm chart, basically at the end of the day, my network function. Why is it easier for me to write a gRPC server than a Kubernetes operator directly?
The Jeffrey will be generated by us. So you have to write the stub. You have to write the stub functions that maps. So supposedly with Kform or whatever the other things is, you're just writing a mapping of the YAMLs. And then
No, I'm saying that why I don't just use Cube Builder or Operator SDK. So vendors, we have an R&D. So if the higher ups decide that yes, we want to write an operator for a network function, why don't we just?
So I know even this is not fully rich consensus among the community, but then when we started the project, obviously there is a API that will interact with the vendors, and then we kind of converge on NF deployment. So NF deployment is what we key on. The specialized ends in NF deployment. In the future, if we have better observability, it watches the statuses of NF deployment. So this is the centralized piece that we surround our stuff upon. So you onboarding Nephio means that you're conforming to our API in a way. So that's why we're making it easy for you to onboard using our API. So that's what it is. Yeah, that's a much larger concept.
I got it. Yeah, just give me.